Hey guys, and welcome back to another episode of Physics Explained. Remember that you can always catch me on Facebook or Twitter at these @tags, and you can always check out the website www.physicsexplained. These episodes also go up on there, and they go up on the Facebook a couple of weeks after they get released on YouTube and the website. But if you want to know when I'm doing stuff, these are the best links to hit, and I usually get back to questions and stuff fairly quickly. And hit that subscribe button if you want to get notified of when I get videos out. Yep. So here we go, let's roll that music. Okay, so carrying on with our series of building up that knowledge basis for more complicated stuff in physics. Let's take a look in this episode at scalars and vectors and what those different quantities exactly mean and how we tell the difference between a scalar quantity and a vector quantity. Okay, so what do we mean when we say a scalar quantity? If you remember back from the last episode, I said that a quantity is anything that has some sort of unit towards it that defines what the number relates to. So on the board here we have an example of some scalar quantities. For example, 30 kilograms, 27 degrees C, and 13 pens. Now the key fact of a scalar quantity is that all it has is a magnitude. That means that the number only dictates a magnitude. And these are often given symbols such as little m or big M for mass, depending on what else is used in the equation for mass. You know, you might have two masses, so you need the difference between a big M, which would be the bigger mass, and a little m, little mass. Or a T for temperature, always given a capital T for temperature because little t is time. And N is usually given for any unit that doesn't have its own symbol. So a scalar quantity is anything that just has a magnitude, a size to its value. Okay, so what makes a vector different from a scalar? The key difference here is a vector obviously has magnitude because we're giving size to some sort of quantity, but it also has a direction. For example, I might say the door is 2 meters away from me, or I might say the door is 2 meters in that direction. That would be a vector because I'm giving some direction to that unit, to that quantity. And the way we do this is because we work in three-dimensional space. We have an x-axis, a y-axis, and a z-axis. We have x-coordinate, y-coordinate, and z-coordinate. Just to illustrate that point further, a vector is made up of its coordinate components. So in this case, because we're working in 2 dimensions, the a vector is made up of the ax component as well as the ay component. And these coordinate systems will have a certain value to them, a scalar value to them. A vector can be notated in 3 different ways. Most textbooks use this sort of way because bold print is quite easy to get hold of. You tend to write them down. Most people use either or, and as long as you define them and stick to them, it's not such of an issue. The magnitude of a vector is notated by using these 2 lines. Sometimes there's an extra line on either side not to get confused with the absolute value, and this is simply the sum of the squares of the coordinates square rooted. So when we draw a vector, we tend to draw it as an arrow. That gives it the direction, and the size of the arrow usually determines the magnitude of the vector. Now let's say in this case A and B are distances covered by, let's say I walk those distances. The distance that I walk will be the magnitude of A plus the magnitude of B, right? Because that is the total distance I've walked. Distance is a scalar quantity. Now if we want to talk about a vector quantity for distance, we use the term displacement. And displacement is the actual as the crow flies distance. And that would be this vector here, this vector C, because that's the start point and the end point of the journey that I travelled. So let me give you another example. This time it will be to do with subtracting vectors. Let's say we have a plane travelling straight up the board with vector A, and we also have a sort of crosswind coming in as vector B. Now we can rearrange these vectors because they operate in the same plane, so that B actually points here. It's the same vector, it has the same magnitude and the same direction, besides my drawing skills. And what we actually end up with is the plane travels this distance here, c. And this distance is equal to a minus b, because this angle here is less than 90 degrees to a. This vector here, this c vector, is the displacement that the plane actually experiences with respect to the land that it's flying over. There is a particular type of vector that I probably should mention at some point, and that's known as the unit vector. Given this little hat symbol above the vector indicates a magnitude of 1. That's useful in many different situations, an example of which is also on the board. This is Newton's gravitational force equation, and in this instance, by including this unit vector, we can determine that this r squared value is just the magnitude of the r squared value, and this gives it its direction. And as though it was planned, a nice segue into what we'll be covering in the next episode, this is an example of multiplying a vector by a scalar. In this instance, both of the vectors f and a point in the same direction. We've multiplied a by some scalar m, in which case mass and acceleration, to extend the vector a to equal the vector f, force. And we'll be covering this a bit later in the next Physics in 5 video, which will be on Newton's laws of motion. Okay, so there you go guys, that's all for this episode, that's all for me today. Remember that if you want to find me on other social medias, or if you want to go check out the website, these are the links. Both Facebook and Twitter are both at Physics Explained. Twitter's a little bit different the way it works. Twitter's a little bit different the way it works. It's at symbols. But yeah, the website www.physicsexplained.co.uk, and remember you can always hit that subscribe button, and it should send you notifications every time I publish a video. Yeah, that's all for me. Thanks for watching.